This video is going to go over the homework from pages 282, 283. So there were some right triangle problems on 282, number 73 to 76. So what they're asking, and I think the directions said not to use a calculator. So the reason why is these are all 30, 60, 90 special right triangles. So in number 73, if we are given the long leg, which is 105, what I'm going to do is find the short leg by taking 105 and dividing by the square root of 3 and then rationalizing that. So I'll get 105 times the square root of 3 over 3, and 3 goes into 105 35 times. So the short leg is 35 root 3, so that's y. And then to get the hypotenuse, you just double it. So 70 root 3. In number 74, similar, but in this one they give us the hypotenuse. So the short leg is half of the hypotenuse, so just 15 halves. And then the long leg is 15 over 2 times the square root of 3. It's a little messy. 15 over 2 times the square root of 3. And we don't want to have decimals and radicals, so we're just not going to use the decimals. We're going to do fractions. So you could write it if you want to as 15 root 3 over 2. And then number 75, they give us the hypotenuse, so the short leg is half of that, which is 8, and the long leg is the short leg times root 3, or 8 root 3. And then number 76, they give us the long leg, so to get the short leg, x, we are going to take the long leg of 38 and divide by the square root of 3. We'll get 38 root 3 over 3. Now that doesn't simplify, so that's just the answer for x. Okay, so x is 38 root 3 over 3, and then r is just 2 times that. So 2 times 38 is 76 root 3 over 3. Then the last two questions were 78 and 81. Okay, so 78 gives us the scenario, and I don't believe they gave us the picture for this one, so we have to draw our own picture. A 25-meter line is used to tether a helium-filled balloon. Because of a breeze, the line makes an angle of approximately 75 degrees with the ground. Okay, so you could draw this a couple different ways. You could draw your triangle. I'm going to do this right here. You could draw it this way if you want, with a 75. Let's see. Oops. Let me do it this way. I'll make my right triangle, because we know we have to have a right triangle in all these. And they're telling me that 75 with the ground. So I know it can't be this other angle. It's got to be the one on the ground. And then it's a 25-meter line. So that's going to be the hypotenuse. That's the length of that line. So this is the right triangle. Make sure you have the right angle marked. And it's 25 meters, and they want us to find the height of the balloon. So I'm going to call that H, so I want to label that. And then part B, so that's part A. Part B wants a trig function. So if I know 75 degrees, and I have opposite and hypotenuse, that's going to be the sine function. So the sine of 75 degrees equals h over 25. Remember, sine of 75, that's over 1. So we can cross multiply and get h equals 25 sine of 75 degrees. And then in the calculator, as long as you're in degree mode, if you hit 25 sine 75, we'll get 24.15 meters. And the last one was number 81. So, C was what is the height of the balloon? So I just found the height of the balloon. That was part C on that last one. Okay. 81, let's see what it says. a biologist wants to know the width W of a river, see the figure, in order to properly set instruments for studying the pollutants of the water. So in this one, they were nice enough to give us the picture. It's all labeled for us. It says from point A, the biologist walks upstream 100, so they tell us that that's 100, and sights to point C. From this sighting, it is determined that theta is 58 degrees. So that angle is 58. How wide is the river? So we want to find W. So in order to do that, we have to figure out if we're given the opposite side and the adjacent side, we're talking about the tangent. So the tangent of the angle, 58, is the opposite side, W, over the adjacent side, 100. And this is over 1, so I can cross multiply. W equals 100, tangent 58 degrees. Now again on my calculator, I have to be in degree mode. And if I plug that in, I'll get my answer of 160.03, since it's an application problem and they had already given us the units. We'll stick with those units feet, so 160.03 feet.